Welcome back to another episode. At this point, we'll be looking at this particular question. And there's another question coming from equilibrium. So it says you're supposed to determine the tension in each cable over here as well. So he said that three cables are used to tether a balloon as shown. All right. So we have this fixed on the ground, and on the ground. So we're having E to B, E to C, E to D. Then various planes has been given to us for us to solve. So at this point, we can see that this is equilibrium problem. So I'm going to use this to explain much in this work. So we can say that any plane that is moving at this direction here should be positive. Then any direction that is moving towards this path should be positive. Then lastly, any direction that is moving up here should also be positive too as well. So we're having our positive y, our positive z, and our positive what? X over here. This is the origin at this point over here. Now we are supposed to solve this particular question together. So let's find for each distances or various direction at which it moves. So first of all, we're going to look at the forces at what? At fx, because we're having 3D planes here, is equal to 0. Some of the forces at y to be equal to 0. Then some of the forces at z is also equal to 0. Now, at this particular problem, you're going to look at the tension at each cable, all right? So we can have a tension at what? A tension at TAB here. So that is it. You can also look at the tension at TEC, go from here to here. Then last, we can have our tension at TAD here too as well. So these two can be in our force form here, a vector force. So that means for us to find the whole of this, we can have the TAB at the X side, at the Y side, and at the Z side too as well. We can have TAC at E, that is from our X, Y, and Z component. Then lastly, our TAD from X, Y, and Z to components as well. So we're going to write all the various values from the TAB2 as well. So first of all, we know that the TAB of this is equal to, you remember very well, we're multiplying the tension here times what? Times the lambda. So if we are multiplying this times the lambda, that means we don't know the tension at what? At EB. So that means you can have EB at S component as what? As Y component and Z component. So it's going to be something like this form. So we're going to have this as our TEB, which is being multiplied by the lambda of what? Of our XI plus our Y what? YJ, then plus our ZK here too as well on square root of all these. So S squared plus Y squared plus Z squared too as well. So that's how it's going to be. Now, we are supposed to find for lambda at each side. So let's see. Let's start from the AB here. So with the AB here, we can say that from this point over here, if we want to know the TAB here, coming from the lambda, so we can have lambda AB here. Let's see from this side. So we're looking at the XI, looking at the YJ, looking at ZK2 as well. So at this point, we can see that this is the EB here. So that means this is the origin. You are supposed to pass through the planes and reach the what? The main position. So since the tension is coming from the EB here, this is where we are going. So first of all, we are going to move from this side to the origin, then from the origin to the what? To the B. So this is how it's going to work. Okay. And we have various values that have been given. So from this to this down here, we are going to have what? We are going to have our All right, so we're going to have from here to this side to be what? 5.6 here. Then from the other side too as well. We're going to have from this side to this, which is what? 4.2 here too as well. So what's our xi? So first of all, let's move from here to here. So moving from here to down, we are moving in y direction form. So that means if anything that's moving to the top is positive, now coming to the down becomes negative. So we are now going to have our negative 5.6 here. That is our what? 60 what? J here. Because we are moving in what? In y direction. Then from here, we are now going to B. So from here to here is also going to be what? Negative. Because any direction that goes here is positive. So if it moves here, it's negative what? Negative 4.2. So we can have plus. So we have negative 4.2 here, 0. Then we can have our I here. Then last, you don't have what? You don't have K component. We just move from here. There's no K. So you can also have what? You can have our 0 what? K here. So that's how we're going to have. So with this, we can easily arrange them together. So that means if we are going to arrange them, we're going to arrange it from I, J, and what? And K here. So that's what we're going to do. So let's do the first one here. So first one, I'm going to have my T, E, B here from this side to be equal to my TEB here as well, right? Multiplied by the whole of the lambda. So this is the whole of the lambda here. So we're having xi. And looking at this is our xi. So it's going to be negative 4.1. Negative 4.20. All right, I here. The next one again, we are going to have, we're going to have our what? Our j. Our j is negative what? Negative 5.60 what? J. Then lastly, our k is going to be what? 0. So that is our z component. All divided by the square root of all these. So you're going to get, you're going to get negative 4.20 all squared plus negative 5.60 all squared. So that is, this is not part because it's there 0. So now our TEB here is equal to our TEB here multiplied by. So let's see. So you're going to have negative 4.20I minus 5.60 J. That is all. So plus 0. So you can divide the whole of this by. So let's see. So negative square root of negative 4.20 here. Okay. Plus the negative 5.60. Okay. All squared. We're going to get them to be equal to. Okay. So let me bring this bracket here so it does not confuse you. Okay, so at this point over here, we're going to divide the whole of this by what? By, so negative 4.20 squared. Okay, then minus, so we're going to have 7 here too as well. So yes, 7. The whole of this is 7. The whole of this is going to be 7, and this one is going to be 7. So lastly, you can actually have our component for this side. We're going to have the whole of this here. So negative 4 point this one here, going to have multiply this by this. Going to have negative, okay, negative 0.6 TAB here, I. Then the next one is going to be negative. So TAB multiplied by the whole of this, we're going to have negative 0.8, okay, TAB what? J. Then lastly, this multiplied by this will give us 0. Okay, so we're going to have 0 here too as well. Then once we are done with the TAB here, okay, so TAB is equal to, so let's bring this one here. We are done with the TAB. Then after we are done with this, now we're going to the next one. The next one that we are going is going to be our EC. So this is our EC here. So we are moving from here till we get to this side. So first of all, let's arrange them together. So first, we are moving from the top to down here, which is equal to the same as this, right? So let's have our lambda 2 here, EC here to be simple. So from here, we are going to have negative 5.60J. Once we come here, now we need to move in this direction. Moving from this direction here, we are moving to positive Z. That is what? That is positive 4 point what? So positive 4.20 watts. So this side K here. Then lastly, we are now moving to this side. Since we are moving to this side, we're going to have 2.40. That is plus what? Plus 2.40. Okay. So 2.40 here, I here. So that is all. So you can also do the same thing to this side too as well. So at this point, we can now arrange them together by getting this side here to be a TEC to be equal to TEC multiplied by the what? By the lambda 2 as well. So that's how it's going to be. So you can easily do it. So we're going to have our TAC from this side to be equal to TAC multiplied by, then we open a bracket. What's our X? That is from the X plane. So the X is going to be positive, right? Because we went here, so here. So you're going to have positive 2.40I. Then the J is going to be negative. So negative 5.60J. Then lastly, plus the what? Plus the key. So it's moving what? 4.2, right? 4.2 to this side here. Because from here, went here. So look at it very well. From this, sorry. So this one is supposed to be the negative. I think there's a mistake here. Sorry. You can see that this one here was negative 5.60 from here. Then went here. This one is 4.2. So that is the key here. Then lastly, the X here. Alright, so this is equal to this here. So positive. So that means that once we have this one is our X, this one is our Y, and this one is the Z. So the Z was 4.2. So it's the same thing here as well. So we have the 4.2 here, 0K here. And don't forget that now we're supposed to find the magnitude for all these. So if you find the magnitude of all these, you're going to have the magnitude of what? Of 2.40 all squared plus the what? The negative 5.60 all squared here. Then plus what? Plus 4.2 here too as well. So 4.20 here all square. All right. So now let's write this well. So from this side, I'm going to have TEC having the whole of this to be equal to the TEC at this side multiplied by, so you have this. Okay, so you can have 2.40 here. Okay, I on what? So the whole of this square root is 7.4. So you're having 7.4 here. And the next one is going to be minus 5 from here. 0.630 on 7.4, right? Then plus the 4.20K here on what? 7.4. Now, once we are done with this side, now we can now see that we can multiply the whole of this through to find for TAC2 as well. So what are you going to get? So you're having TAC at this side, all right, to be equal to. So let's multiply the TAC by this one here. So we can make it two decimal places, 2 as well. So 2.40 over 7.4, going to have 0.32 multiplied by the what? By the T. C here. So we're going to have 0.32 here. All right. TACI. Then the next one, I'm going to multiply TAC by the what? By the negative 5.60 or 7.4, which you're going to get the negative 0.756. So you can make it two decimal places. So it's going to be 0.76 TECJ. And lastly, plus multiplying the TEC by the 4.20K on 7.4, we're going to have our 0 point. So it's going to be 0.567. So one decimal place, 0.57 T E what? T A C K. So that's how it's going to be. Now once we are done, now we are also done with what? The TEC2 as well. So we are done with this. Then lastly, we are going to find for what? Our TAD. So this is our ED over here too as well. So at this point over here, we're going to use the same blue color for it. So this is my ED. So you are coming from down here is what? Is in one negative form. Because we said any direction now goes to the top is positive. So it's coming down. So this to this side and this. So once it comes from here to here, it's negative, right? So negative 5.6. So we're going to have our lambda 2 here. That is from E what? ED to be equal to. So let's do it. So this side becomes negative 5.60 is in what? In y direction. So J. Then once it comes here, it's moving in what? The z direction, but it's in what? In counter form. That is negative. This is positive, this is negative. So once it is moving opposite to this side, that means this becomes negative. So once it's negative, that means it becomes what? Negative 3.30 what? K, because it's in z direction. No x is path. So in that direction. So we're going to have plus. Now there's um no I there, right? So we have 0 I. Then lastly, we are going to have plus. Moving to this side. All right, moving to this side, it's negative z. So you can bring it here. So negative 3.30 here, k here to us. So we are done. So once we are done, we can now bring it here and do them together. So what are you going to do? What we're going to do is we're going to do the same thing also here. So we're going to have our vector here too as well, which is going to be what? The TAD here to be equal to TAD multiplied by what? The lambda. The lambda is the AD that we are going to look for it. So once we have the lambda AD here, can you bring AD, all right, to the various what? It's AC. This one becomes EB to the lambda. You can even choose to do that. You are still correct. All right. Make sure you understand what you are really doing. And based on that, you can easily notify them together. So you can have our TAD here multiplied by, so let's see the lambda. So this one is 0, so we have our 0I. Then we are going to have our what? Minus 5.60J. Then last, you're going to have minus 3.30K here. All in one. So you're going to have square root of, okay, so negative 5 point what? 60, okay, so 60 all squared here. Then we're going to have plus minus 3.30 all squared here. So at this point, what are you going to have? What you're going to have is now, since you now know the whole of the magnitude of this, now we can easily find for what? Our TAD. So now our TAD here, that is in the vector form, is equal to our TAD multiplied by, so this is 0, right? So if it's 0, so the whole of the magnitude of this equation is equal to what? It's going to be 6 point what? 0.5, then minus 5.60 on 6.5j, then minus 3.30 on what? 6.5 what k here. Now once we are done with this, now we can easily multiply them together. So our TAD now, TAD, okay, of the vector form is equal to, so we multiply this by this becomes 0. So now we have the whole of this to be our 0I minus, so we're going to multiply this by this. We're going to have negative 0.86 here, TAD, alright, J. Then lastly, we multiply this TAD by what? The whole of this, which we are going to get negative 0.501 here, TADK here. Now, once we are done, now this is the condition that goes. We're going to sum all the forces at X at one direction. Alright, so all the forces at X side to be equal to 0. All the forces, alright, so all the forces at S 0, all the forces at what? At Y to be equal to 0, then all the forces at what? FZ is equal to 0. So now we can easily group them together. So let's group all the I components together. So now since we are starting with what? The Fx, let's do that one first. So you can say that our sigma Fx at each component is equal to, so let's start with the first one, the TAB for the first one. For the TAB, we know that we had the one in the I direction here to be equal to what? To be equal to minus, okay, let me do it well. So minus 0.6 here, TAB here. Then now we move to the what? To the second one, TAC for the I. In the TAC, we know that we had our positive what? We have our positive over here. So positive TAC. So positive 0.32 TAC here. Then lastly, so I can even choose to use colors for it so that I won't get confused. So this is my I here. This 2 is my what? This 2 is my I here too as well. Then lastly, let's go to the down bottom part. That is TAD. I had 0 here too as well. And I use 0 here too as well. So that means at this point, I had this one to be what? To be my 0, 0 TAD here. So we said that some of the force at x will be equal to 0. So that means if this f of x is equal to whole of this, that means this is now equal to what? To the 0 too as well. So we can make it is equal to what? 0. So equation 1 here. Then after we are done with this, now we are going to the second one too as well. So the second one, how do we go? So we are going to look at some of the forces at what? As at y direction to be also be equal to what? To be equal to 0 too as well. So first of all, let's start with this. So some of the forces at Fy to be equal to 0. So that means some of the force at Fy is equal to, so now we are coming to the J component form. So you also go to the J component form by using yellow for it. So let's see. So let's go to our J. So first, this is our J. So we are having our negative 0.8 for it. for TAC, are having negative 0.76 TAC. Then lastly, we are having negative 0. What? Negative 0. 686 TAD2J. So let's write them together over here too as well. So first of all, I can write this one over here to be my so FY here. So here is what? Negative 0.8 TAB here. Then I now go to the next one here. This is what? The TAC. So negative 0.76 here. TAC here. Alright. Then lastly, you go to the what? The bottom one. That is 0. What? That is so this one is negative 2 as well. So negative 0.862 as well. TAD. Then don't forget that from the question, it says that now from this, it says that this particular, it said knowing that the balloon exerts an 800 Newton vertical force at A. So that is it. So that is moving to the top. So we add the plus what? 800 to what? As well. So if we are having 800 here, so that means at this point, we're going to add what? Plus 800 here too as well. Then we are done with the one for what? For the Y. So let me use this one to separate these two as well. So that is it. Then lastly, we're going to some of the forces at what? At Z. So if you're having some of the forces at Z, we're going to have some of the forces at FZ to be equal to 0. So now some of the force at FZ is equal to, so we can try to also open it up a bit. So let's go to this side. So you can see that at this point over here, we can choose to use green. So our TAC, our is for the key is what? The 0.57 here. Then going to the top here, we had what? 0 here too as well. So 0K. So that is it. Then lastly, we also got um negative 0. What? 51 here. TAD here. So that's what we're going to do. So what we're going to do is now we group them together. So what's our TAB? So TAB at the Z side is 0, right? So if it is 0, then now we write it here. So let's see. So we write 0 here. So first we had 0 here. Then 0 TA what? TAB. Then the next one we had positive 2 as well. So plus 0.57 at TA what? AC. Then the next one we had negative 0.51 TAD2 as well. So that's what we're going to do. So with this, now it's very simple for us to do it by using what? By using our calculator. Okay. Yes. So using your calculator to find for simultaneous equation. Okay. We can easily deduce them. So now let's see. Let's solve them together. Now what we're going to do now is we're going to write everything here very well and arrange them too as well. So first of all, let's rewrite them again. So with this, I'm going to use color orange for it so that everything becomes superb. All right. So let's see. So at this point, we're going to write this one here. So first of all, with this side, I'm going to have minus 0.60 EB here. All right. Then plus 0.32 T. All right. T E C, then plus 0 TAD. So this one will not be included. Is equal to 0. Then the next one we are going to use for the y2. So we're going to have negative 0.8 TAB here. Then minus 0.76 TAC here. Then minus 0.86 TAD. Then don't forget this 800, right? So it's equal to 0. We know from the equation. So it's equal to, so you bring it here, becomes negative 800 here. Then lastly, the one at what the z. So you're having 0 TAB here. All right. Then plus 0.57 TAC here, then minus 0.51 TAD is equal to 0. So with our calculator, you're going to find for various what? Various values over here too as well. So at this point, what are you going to get for all of them too as what? As well. So at this point, we can now say that let me use thing for the values. So our TAB, all right, TAB here is equal to 198 point what? 0.65 here. So 65 Newton. Then our T is